Hello everyone, welcome back to Asamani, and in this video we are going to be implementing some more TensorFlow and learn how to train a TensorFlow neural network model. So last time, if you watched the last video, if you haven't, go watch that by the way. It'll help you install TensorFlow and stuff. So we learned how to create a neural network. So we kind of created it like this, and then we had the summary of the model, and then we just ran that. So when we ran it, let me open up the terminal. Also, you have to have Node.js installed to do this. Node firsttime.js. We have an overview of all of this, and it's really cool. So while I was learning how to how to train a model. So I found that you can actually do it in HTML, which helps to make it way easier to see, and because it's visually based, it's really nice. So what you do is you keep this script tag here by this CDN. The way you can find it is by you go to TensorFlow.js.tensorflow.org, and then you go to Get Started, and then you go to Get Set Up with TensorFlow.js, and then you copy this. So this is what I'm using to run it in HTML. So now, how do we actually create a model? So I'm going to just paste this chunk of code in here, and the reason why I'm doing this is because I was working on creating this type of model and making everything work out. So this is how we make a TensorFlow model. So we'll just move this. Same thing with this. Okay, so let's quickly, I'll go step by step through what each thing does. So I'll keep comments on the side. Okay, so what this const model does is it creates a neural network. And then what this does is we add a layer to the neural network. Add an input layer is what we should call it. Add an input layer to the NN. So I'm just gonna call that neural network as NN. So we want model.add. We do it again. So add a second layer to the NN, and then finally we add a third layer. Add a third layer to the NN. Okay, so you might notice if you're copying the code, just writing down and testing it by yourself, when we did the firsttime.js, we had normal, just input shape. But what does this batch input shape mean? So what happens is when we console.log, so what happens is this array here, right? It kind of has, so when you print it, the actual shape to the console, when we run it, it should be good. There we go. So we see here, when we don't define a batch input shape, we just had the batch. So this is the batch, and then this is the input shape. So the input shape we have already defined as so it says null and 10, right? But you might be wondering, let's say if I change this to like 90 and we rerun it, firsttime.js, it still stays as node 10, null and 10. That's because the batch input shape is always follows. So the input shape, this number is always the last number of units in the layer. So if I change this to 90 this time, so node first time.js, now you see it's null and 90. Okay, so let's go back to our TensorFlow.html. So now what we do is we compile the model. We compile the model, or I should say, and then now gives us in the model.summary gives us the summary of the model. Okay, now comes the fun part. This is the function that we use to train the model. So to train the model, what we do is we create an asynchronous function. And if you're new to JavaScript and you don't know what asynchronous function is, you can use codecademy.com. That's a great website. I'll put a link to it in the description. Let me quickly write that down so I know to put it in the description. Okay, so and then so now so we create an asynchronous function, and so now what we can do is we can train the model. So as an input to our function, we have the model, and the model here is obviously this, because so when we actually run the function down here, so when we train the model, we use this model, and that will be a way to do it. So train, we'll use model. So now let's see how this function works. So we create a function, we create a constant called history, and that and what that does is we await the model. So when you have an asynchronous function, you have this keyword called await that you can use. So so we model.fit, which is so first let's start writing pseudocode. Asynchronous function that trains the model, and model.fit. So this model.fit it tells us how this is the main thing to train it. So what we want to do is we want to be able to train it and optimize it to be able to do it well. So if you see here, when we compile the neural network, what we do is we give it something called an optimizer. So this is what I have given it. You can give it two things. So I've given it this special command called tf.train.sig. I think that stands for sigmoid, and you give it a certain value. But you can do something different. You can also keep it like this, SGD. Both ways are both ways are definitely great ways to train it. Depending on how fast you want to train it, depends on which one you want to use. Now, so back to what we were doing before. So this model.fit trains the model using XS and YS. Okay, so what is XS and YS? So XS and YS are two tensors that I've created here that has that's a tensor, and I just kept 1, 2, and 11 and 12. So one thing that I want to touch upon is a lot of you, if you're trying to do it without like just duplicating my code, is you run into a lot of errors with this input shape property. That's why I want to make it really clear. The batch input shape is useful when you have tensors. Using the batch input shapes makes it so much easier. It is honestly so much easier. And the way you figure out this 2 and 1 is first, how many so the first dimension is how many parameters you have in whatever the tensor you're storing. So this is an array, right? And I have 2 parameters in both of my arrays, so I kept this as 2. And this is the dimensions that it has. So the dimensions that it has is 1 because it's a one-dimensional array. It only goes one way. But if you created like this, where, whoops, that's not what I meant to do. Let's say if you created something like this, then it would be a 2-dimensional array. But I wanted to remain as a 1-dimensional array, so I'm going to keep it like that. So if you see here, we also have the console.models.outputs shape, and so we don't really need that because it's not going to be as useful for what we're going to be doing. So now let's go back here, and so we see here, you might, so this is epochs. So that might sound weird to you. What is an epoch? So an epoch is basically, to my knowledge, how many repetitions you want it to do. So if you say 100 epochs, it'll run 100 times, but it won't run anymore. So depending on how well you want the neural network to be, you can either compromise on time or compromise on the actual accuracy. And another thing you can do here on the model.compile, you can add metrics, and I added accuracy because I want it to be as accurate as possible. So that's why I'm gonna run it 100 times because that's usually the default, because there's something called a loss, and in neural networks, all neural networks have losses. A loss, and that basically means the percentage that it gets it wrong, and we want the loss to so it'll show up as a decimal, but we can convert it to a percent, and we want it to be as little as possible. And the reason for that is because we want it to be accurate. But the thing is, if you want it to be as accurate as possible, you want to give it a lot of epochs so it can run more times and get correct more times. So I'm gonna put number of repetitions. So and now we have callbacks. So this is a callback function, which is always in like callbacks what we want to do. So a callback function, you might have heard of it. It's usually what you want to do after the epoch runs. So let's say we had only one epoch here, and then what we would do is after that one epoch runs, what should we do? So that is a callback, so we've defined that here. So in TensorFlow, there's something called on epoch end. It's it's a command that you can use within the callbacks and the callbacks object, I should say. And so what you can do is you can define a function what you want it to do when something ends. So here I'm running it asynchronously, so it just does it on its own. I don't have to so an asynchronous function. I just created an async function. It doesn't necessarily have to be asynchronous. It can be a normal function. And so we say, callback function, and this is on epoch end, does something when the epoch ends. And what this if statement is, you don't have to use the if statement. I just used it just because if you have a large number, of epochs, what this does is, if the epochs is a multiple of 10, and then it will print the epoch with the actual epochs and then the loss. And then we can also, what we can do is we can add something called the confidence, and then we can add logs. So we can say it would be 100 minus logs dot loss. So now what happens when you run this? So a cool thing that I figured out, and if you're using Visual Studio Code, you can press the run, and then you can press run without debugging, and you can choose Chrome because we're doing HTML, and it automatically opens something up for you. So it seems to be loading. And right now you'll see a white screen, but that's okay because we're just doing HTML, so we can actually see it. So what we see is here we have these two random numbers, 15 and 16. So when we go to the console, so we see NaN. So I think when we add the confidence, I think it's getting confused somehow. So let's just remove the confidence for right now. We don't really need it. It's not that important. So when we reload, it's loading. You see, it's running these epochs, and if you see, every time an epoch runs, so on epoch 0, it's at 124, the loss. But literally in 10 epochs, it reduces all the way down to 13%. So, I mean, not 13%, yeah, 13%. And then on the next 10 epochs, because it's already made of the fundamental changes, now it's just smaller and smaller changes, so the epoch just gets a little bit smaller. And by the end of 100 epochs, it's close to like 6%, which is really nice, because that means we have because if we have a confidence rating, so if we have a loss rating of 6%, that means our confidence rating, if I am not mistaken, I'm not fully sure, but if I'm not mistaken, then that will mean that our confidence rating is 90. It's a 94%, which is honestly really good. And you might be wondering, hey, how is this appearing on the screen? So basically, I only did a little bit of HTML for this one. I created this h1 tag. I just named it with an ID of Epoch. And then when I call the function here, so this checks whether the epoch number is divisible by 10, and then prints epoch and loss. And what this does is creates tensor, and I'll just copy that because it's the same thing for ys. XS and ys are just different tensors. And this is the cool part. So when we call the function, we called train because that's what I named the function, and then we had to give it an input, and we gave it this model. So now, and if you're using ES6 JavaScript, if your JavaScript is up to date, you can use something called .then, which is after the function runs. So once you call this, you then do something else. And what that then is after it's fully done running, then it'll get the element by ID Epoch, .inner.html. If you don't know what this this document.getElementById stuff is, check out my HTML course, HTML videos. I'll put if you watch to the end, I'll put a card on the top. I'll put a card saying the HTML. And now we use something called model.predict tf.tensor1d. So we already have, so we can only get an output from the model from what we give. So because we created two values, one-dimensional tensors, we have to give it one-dimensional tensors. Now, when we rerun it, so rerun it here. Sorry, it's a little bit laggy, but it's fine. But if you see, we literally ran it, and it got to a whopping 3%. That's a 97% confidence rate, and these two numbers are just tensors. But they are really good at giving us back what we want, because I mean, we're getting a two-dimensional tensor. So what this, I think I'm meant to keep this as a 1 because I think it needs to be a one-dimensional tensor. And so, yeah, so when we keep it as a 2 and 1, we usually get 16.3-ish. That's usually the space where we get it. So when you keep the batch input shape, what is helpful is that you usually don't run into those type of errors when you get, the input shape is, actually it'll be easier if I show you right now. So if I say input shape, and I say like 2, and I run it, so it sees here, error when checking input, expected dense once I have the shape 2, but got array with shape 2 and 1. That's why if you just use batch input shape, and then capital, and then you just, even if you run with just 2, I don't think it'll run properly with 2. Yeah, you have to have at least 2 parameters. So 1, 2, even that I think will work. Yeah, oh wait, no, that's wrong. We need to have shape 2, 1 because that's the shape of our array because it's 2 and 1 dimension. So 2, 1. And when we run it, we get this, we have this awesome feeling that we literally just coded an AI. Like, isn't that so cool? Like, knowing we can program an artificial intelligence this easily. I mean, you would think, oh, AI probably is really complicated, but we were literally able to do it. And so we started at line 13, ended at line 35. That's only 22 lines of code. We literally coded an AI in 22 lines of code. That, honestly, mind blown. Like, I am literally mind blown. And so please, if you really learn something and you really like this, please smash that like button. Share the video to other people who you think might like it. Subscribe to Asamani to never miss another video like this. And yeah, thank you guys and have a great day.